Alright, hey everybody. The first thing you need to do on today's notes is fix this. I know someone already told me about this, but I had them printed already before I fixed it. This should not say 4.4. It used to be 4.4, but in this book it's actually 4.3. If you just printed out the notes, within the last day or so, it already says 4.3. So there you go. 4.3 notes. Today we're talking about parallel and perpendicular lines. And if you take a second to look around the room, you will see parallel and perpendicular lines all over the place, especially in the bricks. The parallel lines are the lines that are extending this way, they'll never touch. You also can have parallel lines extending this way, they'll never touch. They can be diagonal and never touch. Those are parallel. And if you look around the room, you'll also see perpendicular lines in the bricks. And perpendicular lines are where your bricks kind of meet here. This right here, this line and this line are perpendicular. They make a 90-degree angle together. So parallel and perpendicular lines are all over the place. We are going to practice. We've been working on linear equations, finding equations. Today we're going to make equations for parallel and perpendicular lines. So there's some unique properties I'm about to show you. Parallel lines, a definition, some of you know this already, are lines that never cross. If you extend them out in either direction forever, they'll never touch. Perpendicular lines are lines that intersect at exactly a 90-degree angle. Exactly 90 degrees. Like a cereal box has 90-degree angles most of the time, unless you squish them. So because of this, we've defined them to be like this. That means if there are two lines for parallel lines that never, ever, ever cross, that means that their slopes are exactly the same. So they have exactly the same slope. Symbols for parallel, I write it like this. Some books are going to write them a little differently, but if you see me write a slope parallel symbol, I'll write it like that. That means parallel. And a picture, if we drew this on a coordinate plane, we could have lines that are extending like this at exactly the same slope. It's like if we go back to our translations that we did in chapter 3, it'd be like this line just translated or shifted diagonally, or we could shift it up, we could shift it down. It's the same line with the same slope. We're not rotating, we're not stretching or compressing, we're just translating. These two lines are never going to touch. They have exactly the same slope. If you had your guy walking on here, he'd be walking on the same increase on both places. And these two guys, if they kept walking forever, would never touch. Perpendicular lines have a special slope property. And if we had more time in class, we would do like an exploration and you'd discover it on your own, but we don't have that kind of time. So the slopes for these perpendicular lines are what we call opposite reciprocals. Opposite reciprocals. Opposite is referring to positive versus negative. Reciprocal is referring to switching a fraction. So if you had like 1/2, you would switch it and it would turn into 2/1. So reciprocal, but we want the opposite reciprocal. So we'll practice this. The symbol for perpendicular is an upside down T. I'm going to show you two pictures for perpendicular, because sometimes it can be hard to tell. You could have a vertical line extending in this direction forever and a horizontal line extending in this direction forever. They're intersecting at a 90-degree angle. That's usually pretty clear. But sometimes they can be on a diagonal. You could have a line like this and a line sort of like this. That wasn't a very good drawing, where they intersect at 90 degrees. But when you're looking at it, it's like tilted. Okay, that's your intro. Parallel, perpendicular, we're going to practice writing equations. The whole point is I want to know, if I give you one of these lines, what's the equation of the other line? All right, let's jump into our examples here. Write an equation that passes through this point, and it's parallel to this equation. So I want to show you a picture. You don't have to draw a picture every time, but I want to give you this visual representation. So if I had this line graphed, it'd be at -4. It'd be up 1 over 2. I'd have a line sort of like this. And then there's this random point out here at 4, -2. So I'd go right 4, 1, 2, 3, 4, and then down 2. So the whole point of this problem is I'm trying to find a point that goes through this point, this yellow one, and that's parallel to my black line. So I need to write an equation for this line based on what I already know. We've been working on writing equations, so you guys are champs at this. We always start with what we know. We know. So I like to do it like this. I like to do the old slope, or the first slope, the original slope. I am going to use this equation right here for one thing and one thing only. After I get my one thing, I'm going to get rid of it because I don't need anything else from it. I only need the slope. This type of equation is parallel. Parallel lines have the same slope. So my new slope is going to be, guess what? Also 1/2. This is my m value, 1/2. And that's all I really need. The rest of this is a review. We've been doing this for 2 days now. We start with our equation, y equals mx plus b. We plug in what we know. Remember, a point always tells us x and y. They're very useful. They have two pieces of information. So I'm going to plug in -2 for y equals, well, what was m? M is my slope, 1/2. X, we're plugging in 4 from my point. And then I don't know what b is still. I'm going to solve for it. -2 equals 1/2 times 4 is just 2. Plus b. Be careful here when you're solving. -2, -2. -2 minus 2 is not 0. It's -4. 2 minus 2 cancels. Bring the b down. So b is -4. And if you're remembering what I've been saying for days and days and days is we need 2 ingredients. We are math chefs making some cookies with our 2 ingredients. We need the slope, or I'm sorry, this is the y-intercept and the slope. We have our 2 ingredients. Now we're going to put them together to make an equation. Y equals 1/2 x minus 4, and then you're done. This right here is the equation for this line. Okay, let's try another one. Write an equation for the line that goes through this point, and it's parallel to this one. I'm not going to draw my picture. I'm just trying to give you an idea of what's going on here. So I need to know my old slope from this equation right here is 4. Once I get that, I'm going to scribble this equation out. It does not do anything else for me. The type of line is parallel, because they tell me in the problem. So that means my new slope, M, is going to be 4. Y equals mx plus b. I still have an x and a y. I can plug in 2 for y. My slope I found over here is 4. X was 1 plus b. 4 times 1 is 4. To get b by itself, we can subtract 4 on both sides. 2 minus 4 is -2 equals b. So I have my 2 ingredients, 4 and -2. So my equation would be y equals, be careful you don't mix them up, it's mx plus b. So y equals, the m we had was 4, it's the same slope as the original line, but it's a different y-intercept, so this time it's -2. So if you graph these two lines, the one that I scribbled out and this one right here, you would find they're parallel. They have the same slope. They just have different y-intercepts. Just like the translations that we learned. Whoa, everything comes back to that section. It's an important one. Okay, this one, I think I might have made a mistake and picked the wrong point here, because you shouldn't have gotten the same equation, but the process is the same. If I was there, I would maybe change it, but I'm not there, so you have a correct example solved out here. Thank you, and you're welcome. Okay, let's try. So that was parallel. Both of those were parallel examples. And if you were going to make a prediction, what do you think would come next? Perpendicular. We're going to do 2 perpendicular examples. So this time, we are going to write an equation for the line that goes through this ordered pair and is perpendicular to this equation right here. So we kind of have a line. Let's say that my line looks something like this, and I'm going to have a point -4, 6. So I'm going 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. There's some point over here that goes through this line that's going to be perpendicular to my green line. I'm trying to figure out the equation, write an equation for this purple line. It's amazing how you can do it, honestly. I feel like this process is just, it blows my mind every time. So this time we're going to start with our old slope, or the slope of the original line is 2/3. Once I have that slope, I'm not using this equation at all anymore. You can scribble it out. This time the type of line is perpendicular. Perpendicular. That means I'm going to do opposite, reciprocal. Reciprocal. So in order to get my new purple slope, this 2/3 is going to change. It needs to be opposite. That means right now it's positive, so opposite means negative. Positive turns to negative. Reciprocal means flip. 3/2. But it's going to be, did I lose my negative? That was supposed to be negative. I didn't hit a fraction. Whoops. Negative 3/2. It was positive, 1 to negative. 2/3 becomes 3/2, 3/2. 2/3 is 3/2. That right there is my new slope that's coming down here. These are opposite reciprocals. So negative 3/2. Once you have that, remember new slope, this is m. We have all the pieces. We have one ingredient. We can find the other ingredient though. Y equals mx plus b. We've got x and y still. So 6 is going in for the y. M is this m right here, negative 3/2. That's what we just found. X is going to be the x from our point, negative 4. And we still don't know what b is, so that's just plus b. In your calculator, I want you to type in this, negative 3 divided by 2, that's how you do fractions, parenthesis negative 4. We get a nice number, 6. So I'll have 6 equals 6 plus b. Subtract 6 on both sides. 6 minus 6 is 0. So b equals 0. And now I have both my ingredients for my purple line. B equals 0. Slope is negative 3/2. So my final equation would be y equals negative 3/2, negative 3/2x, plus 0. I'm not going to write that because plus 0 doesn't add anything to our actual equation here. If you think about that, it should make sense. This means that the y-intercept was 0. And my sketchy drawing over here actually was pretty accurate. It looks like it's going to be right here through the origin. And if we graphed it on our fancy calculators, and you wanted to check to see, like, does it approximately look right, I could type in this equation I canceled out. 2/3 x plus 4 over negative 3/2x. Graph. So here's my blue line. That was the green one from my picture. And then here's the red line. And then these equations is really not perfect because the calculators, I have to change this to a square. Otherwise it's not going to look quite right. I did that by Zoom Square. And when you look at this, man, that looks pretty close. No one's drawing on my calculators. Okay, it looks pretty close. I mean, wow, that's impressive. That's some cool math right there. But you have to go to Zoom Square to make it work, number 5, Zoom number 5. Okay, we're not going to do that every time. I just wanted to show it to you and hopefully get some brain connections going. Okay, let's try this next one. Write an equation for the line that goes through 1, 2, and it's perpendicular to y equals x. Oh dear, this looks a little different. What's our old slope of this line right here? Y equals mx plus b. There is no m. There's no number in front of it. It's imaginary. It's the number 1. Our old slope is 1. The type is perpendicular. So you should already be thinking opposite, reciprocal, op-recip. So if I had the slope 1, 1 is really like 1/1, that's going to turn into, this is positive, we're going to change it to negative, and then flip them. Negative 1/1, which is really just negative 1. So our new slope, m, is -1. Well, the rest is pretty straightforward from there. Y equals mx plus b. We have an x and a y. Y is 2. M we said was -1. X is 1 plus b. 2 equals -1 times 1 is -1 plus b plus 1. So 3 equals b. That's one ingredient. Slope ingredient. So the equation is -1x plus 3. Or if you really want to be sophisticated, you could write it as y equals -x plus 3. So this is where I pause to coach you, because I'm sure some of you are feeling a little bit like, ooh, I'm not sure. I'm kind of with you, or maybe you're feeling a little stressed. I know I'm not there to give you some reassurance, but I can do it through the video and preempt it and say, most of this, you guys have been rocking the last 2 days. Most of this is just this part of the equation. The only thing that's different is the slope. Parallel lines are easy. They have the same slope. We're just borrowing the old slope and applying it to our new equation. That gives you your ingredient, and then you solve and you're done, like we've been doing for 2 days. Perpendicular lines, the only new piece of information really here is opposite reciprocal, where you have the number, you flip it and change it if it's positive to negative, if it's negative to positive. Okay, you'll have some on your homework that look like this. You have to decide, are they parallel, perpendicular, or neither? Well, to decide, you have to look at the slopes. And in order to look at the slopes, they have to be in slope intercept form. Like y equals mx plus b. We're looking for m. So in our first example here, our slope was -2. Now let's look at this equation. We don't actually know what the slope is. It's not in y equals mx plus b. We need to get y by itself, so we can subtract 2x. This is what we used yesterday. So we get -4y equals -2x plus 4. To get y by itself, we're dividing all three of these by -4. Y equals -2 over -4. If you weren't sure, -2 over -4. Don't write 0.5. Doesn't help us. Math enter enter is 1/2. 4 over -4 is -1. What's the slope of this line? Slope equals 1/2. So you have to decide, is there a pattern or a relationship between -2 and 1/2? Are they going to be parallel? No, because they're not the same number. So the real question is, are they perpendicular? Perpendicular lines are opposite reciprocals. Is one positive and one negative? Yes. Is 2 over 1 the reciprocal of 1 over 2? Yeah. If I had -2 and I want to do the opposite reciprocal, I would change it to positive. This is 2 over 1. Flip them. This would be positive 1 over 2. That's what I have. So these two lines are perpendicular. Done. try the next one. Oh, we'll start with the easy one. Slope is -6. I'm going to rewrite this equation down here. Let's do 6x plus 2y equals 11. We need y by itself. Subtract 6x. So 2y equals -6x plus 11. And how do you get y by itself? Divide by 2. Y equals -3x plus 11 over 2. Is -3 the same as -6? No, they're not parallel. Is one positive and one negative? No, so there's no chance of them being opposite reciprocals. So this is just neither. There's no relationship between -6 and -3. And on this last one, we could solve this. We had 3x minus 4y equals 12. Subtract 3x on both sides. So -4y equals -3x plus 12. Divide by -4. So y is -3 over -4 is 3/4. X minus 3. So I'm looking at the slope 3/4. This situation here, I'd minus 4x. -y equals -4x plus 12. Divide by -1. -4 divided by -1 is +4. Is 4 and 3/4, do those have a relationship? No, so this is also neither. If they were parallel, they'd be the exact same number. Okay, it's the same content, just in a different set of information here. And then you have a couple geometry application problems. They want to know, this means line segment AC, so on my graph it'd be the line segment from A to C. Is that parallel? Yeah, the book uses up and down lines. Parallel to BD. Oops, this is a B, it got cut off. Is it parallel to BD? Well, does it look like it? You bet it does. But you have to prove it. We need two ordered pairs right here. This is the ordered pair 0 up to 6. And this is the ordered pair, I'm going to go -6 up to 4. Can I find the slope between those 2 points? Yes, I can. I'll show you in a second. Let's find the slope of this point right here. This point is the point -2 up 12. This point right here is the point -8 up 10. So I'm going to use these 2 points with my slope formula. So the slope of AC would be 6 minus 4. y2 minus y1 over x2 minus x1, so 0 minus -6. 6 minus 4 is 2. 0 minus -6 is, this is a plus, so it'd be 6. So m is 1/3. If they're parallel, these should be the same. So for AB, I'm going to use these points right here. 12 minus 10 over Negative 2 minus negative 8. 12 minus 10 is 2. Negative 2 plus 8 is 6. Oh, look at that. 2, 6. So m equals, m is 1/3. Are these two slopes the same? Yes. So these are these two parallel? Yes. Are you going to have one like this on your test? Yes. Are you going to have one like this on your homework? Yes. Do I need to see your work? Yes. So yes, these two are parallel. We proved it, not just by sight, not just by eyeballing, but by showing that their slopes are the same. Last one, then we're done. You guys have been good. AC. Oh, that's this point right here. Oh, good. I already know the slope of that one. What was the slope of that one? 1/3. Is that, this symbol means perpendicular. Is this green line perpendicular to, let's use my yellow line here. Well, let's find the slope of this one. y2 minus y1, 12 minus 6, over negative 2 minus 0. 12 minus 6 is 6, over negative 2. M equals negative 3. The question is are these two slopes opposite reciprocals? If I had the number 1/3 and I'm doing the opposite reciprocal, I'm taking this positive and making it negative, and I'm taking the 3 and the 1 and I'm flipping them. So is positive 1/3 the same as negative 3 over 1? Or are these opposite reciprocals? Yes, they are. So are they parallel? Perpendicular? Yes, they're perpendicular. Do I need to see you show your work? Yes. We're finding the two slopes. These are the your homework problems. Oops. But sorry guys, I gotta switch these around. I had the wrong problems on here. I actually have less work than that. You're welcome. So if you have my printed notes, you're gonna need to scribble them out and write the right numbers down. 243, we're doing numbers 11 to 20. (33 to 35). And 49 to 51. Those are just multiple choice. Okay, I'm cutting it down a little bit. You're welcome. All right, there you go.